Have you ever wondered how the quantitative description of geometric or physical entities changes with a change of basis? Today, we'll embark on a journey to explore the intriguing concepts of covariance and contravariance. Imagine you're at a bustling market and you've just bought a basket of apples. You could describe the amount of apples you have in different ways. You might say you have a basket of apples, or you could count them and say you have 20 apples. Now, if you change your basis of measurement from a basket to individual apples, the number you use to describe your apples changes. This is similar to the concept of contravariance in physics and mathematics. In the world of vectors, a contravariant tensor is like your basket of apples. When you change the basis vectors, the components of your contravariant tensor change in the opposite way. For instance, if you switch your scale from meters to centimeters, the components of a position vector increase. This is because you're now measuring in smaller units, so it takes more of them to describe the same length. It's like saying you have 20 apples instead of one basket. On the flip side, there's covariance. Think about a recipe that calls for 2 apples. No matter how you choose to measure your apples, whether by individual count or by baskets, the recipe still requires 2 apples. This is akin to a covariant tensor, whose components change in sync with the basis vectors. A covector or dual vector is an example of a covariant tensor. It's not actually a vector, but an object in a dual vector space. In simpler terms, if contravariant tensors are like the ingredients in your recipe, covariant tensors are like the recipe itself. The ingredients can be measured in various ways, but the recipe always requires the same amounts. Now, it's important to note that tensors can have aspects of both covariance and contravariance. Yes, it's like a recipe that sometimes measures ingredients by weight and other times by volume. The way these measurements change when you switch from one system to another helps us understand how vectors and covectors behave under transformations. To summarize, contravariance and covariance are concepts that describe how the description of geometric or physical entities changes with a change of basis. Contravariant tensors change in the opposite way to their basis vectors, much like changing your measurement from baskets to individual apples. Covariant tensors, on the other hand, change in sync with their basis vectors, similar to a recipe that always calls for the same amount of ingredients, no matter how you measure them. These concepts are vital in physics and mathematics, especially when dealing with curvilinear coordinate systems and transformations. So the next time you're at the market or cooking from a recipe, remember the intriguing dance of contravariance and covariance.